Solving linear programming problems graphically. In this module, you will learn how to solve linear programming problems graphically. Resources may be limited in many areas such as agriculture, military, industry, medicine, and transportation. These resources may be manpower, material, machine, time, and money. To minimize cost and maximize profit, it is important to optimize the use of these resources. The use of these resources may be optimized by resource planning. Resource planning is done in mathematics using a method called linear programming. Linear programming consists of two words, linear and programming. Programming means planning, and linear means the relations involved in planning are linear. So, linear programming is a method used to find the maximum or minimum value of a linear function. A problem where we need to find the maximum or minimum value of a linear function is called a linear programming problem. Let us consider an example. Suppose a retailer has rupees 3,000 to buy toys. Say a toy car and a toy truck. A toy car costs rupees 40 and a toy truck costs rupees 20. If we assume that the number of toy cars and toy trucks to be purchased are X and Y respectively, then 40X plus 20Y must be less than or equal to 3,000. The retailer has a storage capacity of not more than 100 toys. Thus, the sum of X and Y is less than or equal to 100. Since the number of toy cars or toy trucks cannot be less than 0, we get X is greater than or equal to 0 and Y is greater than or equal to 0. Now if the retailer can sell a toy car at a profit of rupees 7 and a toy truck at a profit of rupees 10, what number of each type of toy should he purchase to maximize his profit? The profit of the retailer is given by 7x plus 10y. If we represent the profit of the retailer by z, we need to find the value of x and y for which z is maximum. Such a function that needs to be maximized or minimized is called an objective function. We can see that the objective function satisfies some limitations represented by the inequalities. These limitations are called constraints. The inequalities that represent non-negative restrictions of the problem are called non-negative constraints. Now let us find the maximum value of z graphically. First, draw the graphs of the constraints. Now shape the region that satisfies the constraints and the non-negative constraints. This region is called the feasible region. The maximum or minimum values of an objective function always occur at the vertex of the feasible region. So, find the vertices of the feasible region. Next, substitute coordinates of all the vertices in the objective function. The largest numerical value of Z represents maximum profit. Make a dot at the vertex that gives the optimum value of the objective function. The x and y coordinates of this vertex represent the optimum number of toy cars and toy trucks that the retailer should purchase to earn maximum profit. So, we can solve any linear programming problem graphically using the following steps. First, identify the constraints and objective function. Then, draw the graph of the constraints. Next, shade the feasible region that satisfies all constraints and non-negative constraints. Next, locate the corners of the feasible region and determine their coordinates. Then, compute the value of the objective function at each corner. Now select the optimum numerical value of the objective function. Finally, locate the corner that represents the optimum value of the objective function. The coordinates of this corner represent the optimum solution. In this module, you have learnt how to solve linear programming problems graphically.